that your homework is, all the assignments that I had opened up is due tomorrow at midnight. So just keep that in mind. So that's homework and quizzes. Of course, the exams you've already done those, so those are not open. So if you wanted to again get your grade up, or if you're finishing up chapter 7, just make sure that's due tomorrow at midnight. So the other thing I wanted to talk to you, since we didn't get to do that, before we went on Thanksgiving break, was that I did get a chance to speak with my department chair, and she said, just under the special circumstances that we are, with the pandemic and everything, she said if I wanted to give the final early and you guys wanted to take it early, then we can do that. So I just kind of wanted to see, what did you guys think about taking your final, on Wednesday, which would be December 2nd?
When would we be having it if we didn't do it then?
If we don't do it then that would have to be, what is it, Monday the 7th?
All right.
Yeah, Monday the 7th, because again, there's no reason for us to wait till Wednesday the 9th, because honestly, I don't have anything else for you guys to work on.
So we take the final Wednesday. What would we do after that then?
As far as this class would be concerned, you would be done after the final. Then you could work on whatever other classes you are taking. If you have other assignments that you need to be working on, you would work for that. But as far as our class goes, if you take your final on the 2nd, which is this Wednesday, then you don't have to come to class next week. And, obviously that would not count against your attendance or anything like that, because, that's a decision we're making. So you would still get full attendance credit. We would just obviously not count those days as part of our class days. So whatever your attendance would be through Wednesday would be your attendance for the entire semester.
Right.
You need to get a sense from all of you. So I'm seeing some answers coming through the chat. Jack, Brandy, and Elena, you guys said yes. Katie, Braden, Hannah, okay. Angelo, you're also wanting to do it earlier, okay. Anna. And Mikhail, that's fine. If you think you want to wait till the 7th, we can do that also. So what I would offer is then those of you who want to take it on the 2nd, let's go ahead and set you guys up for the 2nd. Mikhail, you can take it on the 7th. I don't know if you wanted just a couple extra days. You can also take it Thursday morning, which would be the 3rd. So it's really entirely up to you. You can take it with some of the other sections. And if you guys want to wait till the 7th. Maya, you said same. I'm not sure. Are you saying same to Mikhail's answer or to the ones earlier than that?
Mikhail's answer.
Okay. Okay, yeah, so those of you who think you want to wait and decide what to do, that's fine. What I would say in that case is just show up to class on Wednesday and let me know what you have decided to do. Okay, so yeah, we will not hold it against you or anything like that, because, that's not the idea behind taking the exam early. My idea was just, since I don't really have any other things to lecture on, we've talked about everything, we'll be looking at the practice again today, just to make sure you guys are comfortable with the questions. And so, that's the reason why we're taking it earlier. So yeah, those of you who think you would need a little bit more time, I would say just, take these next couple days, see how you feel. And if you're still of the mindset that you want to wait, then, come back on Monday morning and take your final then. Okay. Yeah, go ahead, Maya.
With the final being done, would we still have the algebra lab class?
No, because again, honestly, even for today, we don't have anything to discuss, because the fractions that you guys worked on last week was the last assignment that we were going to be working on. So I was again going to use today's lab more as a Q&A session, again, give you guys a chance to ask any questions if you wanted to, but we don't have an assignment to work on per se.
Um,
Go ahead.
sorry, hold on. There's a bit of noise. I'm gonna talk through the chat.
Okay. So while Mikhail's sending his question, any other thoughts that you guys might have on this? Concerns, thoughts?
So would today basically be like the review day?
Today would be review, yeah. Okay, Mikhail, not a problem. That's fine. So yeah, I just wanted to make sure you guys were, comfortable, ready for the final. So let's go ahead and take a look at some of those questions we didn't get a chance to look at last time with our practice exam. Okay, so let's see, that's the one we were looking at. Okay, so let's see, can you tell me what do you think we need to do on a problem like this? What would you do? This is, of course, coming from the exponential section. So this is chapter 4. So how would you set this up? Go ahead, Katie.
Since m of x equals e to the power of x, wouldn't it be, wouldn't the e's cancel out and then it'd be x equals 1 over 7? No, not x equals, not 1 over 7.
Not 1 over 7, yeah. What else would it be? Because, both of these are m of x function, which means you can actually set these guys equal to each other. So you've got e to the x equal to 1 over e to the 7. Yeah, Brandy, very nice. You can rewrite the right-hand side, move this to the numerator. So you can rewrite this as e to the negative 7. So you've got e to the x equals e to the negative 7. So what happens then? What do we get for x? So what do you get for x here? Very nice, yeah, because this is coming from that one-to-one property for exponential function. So yeah, good job, guys. This will come out to be where your bases basically will be gone and you just have x equals negative 7. Because remember, when bases are the same, you can set your exponents equal to each other. So very nice, x equals negative 7. That looks good. And since I'm actually in the teacher mode, it does let me check the answer. So you can see that's the correct answer for this one. All righty, very I honestly don't remember if we had talked about the switch and solve method last time. But this one, remember, you can use the switch and solve method, or you can try and find the inverse mentally. So it would be basically whatever method you are comfortable with. If you are a little bit unsure about the mental calculation process, you can always stick around with the switch and solve method. So with the switch and solve method, and this is coming from chapter 2. This is section 2.5. So with the switch and solve method, of course, you take your f of x and replace it with y. So you would have y equals cube root of x minus 3. Now remember, the switch happens where you interchange the places for the x and y variables. So x will come outside, y goes on the inside, and then the solve is basically where you're trying to get the y by itself. So the first thing, if you want to get y by itself, would be to get rid of the cube root function. So of course, if it's cube root, you can take both sides of your equation and raise it to the third power, and that would help you get rid of that cube root on the right hand side. And then you can see, of course, you're just left with y minus 3. We've got x to the third power on the left hand side, and then all you do is add 3, and you have your inverse function. So x to the third power plus 3, and then of course just replace that y with your inverse function notation. So switch and solve method definitely, like I said, will work every single time. Now, if you wanted to do this mentally, then remember, for the process, if you're doing this mentally, is you have to do the opposite operation and you have to go in the reverse order. So if you look at your function over here, if we look at our x variable, you start with the x. The first thing we would have to do is subtract 3 from whatever number you have for x, and then after you have done the subtraction, then you would be taking the cube root. So for the inverse function, we would have to go in the reverse order, and we would have to do the opposite operation. So you can see, since you did the cube root last, we would have to do the cube function first, and then since we did the subtraction first, we would have to do the addition last. So like I said, go in the reverse order and do the opposite operation. So as you can see here, for the inverse function, you would have to take x to the third power first, and then we would have to add the 3. So either of these processes, will give you the same answer. It just depends on which one you are more comfortable with. So any questions on finding the inverse? Okay, let's check this one here again. And you will see they're telling us our input is correct. The one thing I will again remind you is, when you are working with these inverse functions and your original function happens to be a rational function, remember, something like 3x plus 2, I don't know, divided by 7x plus 5. Because some of these examples are going to have these rational functions. For this guy, my recommendation is definitely to use the switch and solve method. Because we had tried doing this mentally in class, and you will see it did not work out for us if you go back and look at those lectures. So for this kind of an example, when they ask you to find the inverse, use the switch and solve method. Okay, this is coming from chapter 5, where we were talking about solving the system of equations. So any ideas what you would do here? It's blurry. Okay, give me a second over here. Randy, did that make it better or no? Yeah? Okay, very good. Maya, is it still blurry after I re-shared my screen? Yeah, it's still blurry. Okay. I am not sure. Let me check my internet connection. Okay, looks good. All right. Let's see what's going on. I had some other windows open. I'm going to try closing them and see if that makes it better, since I won't be using as many resources. Alrighty, let's try this one more time. Did that make it any better or no? It seems better to you, okay? A little, Braden, okay? Okay. Alrighty. So like I was saying, this is coming from, chapter 5, section 5.2, because that's where we had talked about the system of equations with, 3 variables. So again, what kind of strategy would you use here if you had to solve this? It's blurry again. Yeah, I wonder if that's happening when I try to write on it and if that's making it blurry. Angelo, is it still blurry?
Yeah, it's still really blurry on my side.
Huh. Interesting. Okay. It's funny, they were just talking about this company Zoom on the radio this morning, and they were saying how their stocks have gone up. Everybody obviously is practically using Zoom, and I think Zoom just got a big head, and now it doesn't want to work for us. Okay, so if this is not giving you a clear picture, what can we do? Let me see what kind of settings I have up here. It seems to get worse, okay. Just got bad again. No, I am not sure why it's doing that. Okay, it's gradually getting worse. Interesting. Let me see. Okay, that wouldn't have been. What else do we have here? Is it still bad? Okay. Well, let's try and use it as much as we can. I will try to leave my annotation off just to see if that makes any kind of difference. So I'm not sure how we're going to work around it. It's getting worse again. Okay, give it a minute, because I think since I just zoomed in a little to make the problem a little bit bigger, it's probably taking a little bit of time to adjust. But it's funny, it's showing I have good internet connection at my end. Picture. Says, how about okay, so this one here, you have the different that have, or the different coefficients. Mikhail, okay. So you've got positive 4x, positive 1x, and positive 11x in the 3 equations. Then you've got positive 3y, negative 3y, and negative 2y. Then you've got positive z, positive 2z, and positive 3z. And then, of course, on the right-hand side, equal to, you have 1, 4, and 13. So which variable would you eliminate, the x, the y, or the z? Maya, very nice. Yeah, the y variable makes sense because you already have that built-in negative sign with the second and the third equation. So you definitely want to start by eliminating the y. And additionally, again, I'm kind of scared to do anything on my screen because I don't want stuff to disappear again or get bad for you. But since you have positive 3y on the first equation and negative 3y on the second equation, it makes sense to eliminate, again, the y variable by adding, and see if it let me write on the screen without making it too bad for you guys. And I'm actually going to see if I can hide some of this stuff so it's not taking up as much of the bandwidth. So we are talking about eliminating y. And to eliminate y, if you think of this as our first, second, and third equation, we can actually go ahead and add equations 1 and 2. And that would help us eliminate the y variable. So if I am adding the first two equations over here, you can see 4x plus 1x will add up to 5x. Positive 3y, negative 3y will cancel each other out. Then you've got plus 1z and plus 2z. The 2 plus 1 will add up to 3z. On the right-hand side, you've got 4 and 1. So 4 plus 1 will add up to 5. And we can call this as equation 4. Okay, so since we added equations 1 and 2 to come up with the fifth equation, you can add either equation 1 and equation 3, or you can try and add equations 2 and 3. But just looking at the plus and the minus sign, it kind of seems that it would work a little bit better if we added equations 1 and 3. So with equations 1 and 3, what would we need to multiply our equations with so that we could get rid of our y variable? So you've got positive 3y here and negative 2y over here. So what could we add or multiply each of those equations with to try and add? Let me see what you have. Brandy, you can see it now. Okay, that's good to know. So what do we multiply equations 1 and 3 with? Very nice, yeah, because you want to actually find a common factor of 6. So let's see, Mikhail and Maya, you guys have multiply equation 1 by 2, multiply equation 3 by 3. Alrighty, very nice. So we're going to take the first equation, multiply it by 2. We're going to take the third equation and multiply it by 3. So that would actually end up giving us 4 times 2 will give us 8x. And you're multiplying 2 times equation 1 and 3 times equation 3. So let's see, 8x, 3 times 2 will give us 6y. 1 times 2, of course, is 2. So 2z. And then 2 also on the right-hand side. For equation 3, 11 times 3 would, of course, give us 33x. Minus 2 times 3 will be negative 6y. 3 times 3 will be 9z. And then, let's see, 13 times 3 is what, 39? So now that we have our multiplication taken care of, we can go ahead and add these two equations. So you will see, of course, that positive 6y and negative 6y cancel out. We're adding, let's see, 33 with 8. So that will give us 41x. 9 plus 2 will give us 11z. 39 plus 2 will give us 41. And this will be our equation 5. Because remember, when you're working with these system of equations with 3 variables, we always want to try and reduce it down to a system that has only 2 variables and 2 equations. So that's exactly what we've done. So our new system now looks like 5x plus 3z equals 5. This is equation 4. And then let's see, we've got 41x plus 11z equals 41, and this is equation 5. So now you again want to choose one of those variables and eliminate it, and find the one that's left behind. So here, what do you want to eliminate, the x or the z? Which one do you think would be easier to eliminate in our equations 4 and 5? Yeah, I was kind of thinking z also, because you would be working with smaller numbers in this case. So since you can see both of these are positives, one of these equations we would probably need to multiply it by a negative number. So what do you multiply equation 4 with, and what do you multiply equation 5 with? Okay, let's see, you're talking about number 4 with 11, and then looks like negative 3 for the second one. So multiply this guy by negative 3, the first one by 11, okay? So let's see, when we add these guys together, you would end up with, multiply. 11 times 5 would give us 55x. 11 times 3, of course, is 33z. And again, we would have 55 on the right-hand side. Let's see, 41 times negative 3 will give us negative 123x. Of course, we would have negative 33z over here. And then again, we would have negative 123 because you're doing 41 times negative 3 on the right-hand side. And then when you add this, your positive 33, negative 33z's cancel out. We've got negative 123x, and you are adding 55 to it. So as you can see, that will come out to be negative 68x. Z is gone. Same thing on the right-hand side. You're adding 55 with negative 123. So we get negative 68. So what's your x value over here? What do we get for x? Positive 1. Yeah, very nice, because, of course, we would end up dividing both sides by negative 68. Negative times negative becomes positive. 68 goes into itself once. So we have our x value. Now, once you find your x value, you would go back to equations 4 or 5, and you would need to find the z value next. And honestly, you can use either one of them, but I think I'm going to go with equation 4 to help me find the z value. So can you tell me what you come up with for the z value? Z equals 0, okay, Mikhail and Katie. Yeah, 5 times 1 will give us 5. So when you subtract this 5 and take it to the right-hand side, you end up getting 3z. 5 minus 5 will be 0. So yeah, very nice. And you know, of course, when we divide both sides by 3, you end up getting z equals 0. So using equations 4 and 5, we were able to come up with our x and z values, which means now, you know, we can go to our one of the 3 original equations and find the y variable, and we will be done because we will have all 3 of our variables. And I guess you can use any one of them, but I will go ahead and use the first one. So we've got 4 times 1 plus 3y plus z, which is actually 0, equals 1. So again, what do we end up getting for our y variable over here? -1 for the y variable. Alrighty, then looks like Brandy and Katie, you guys have the same answer. So very nice. 4 times 1 is 4. So again, we will end up subtracting 4 from the right-hand side. You know, 3y plus 0, of course, just comes out to be 3y. And then 1 minus -4 will give you -3. So very nice. Divide both sides by 3. And you will see that is where we end up getting y equals -1 from. Okay, so your ordered triple is basically going to be so our solution set with the ordered triple, we've got +1 for x, -1 for y, and 0 for z. So that would, of course, be one solution, part A, and then we're putting in +1, -1, and 0 in here. Oops, didn't need to do that. Okay, let's check that, and you will see they're telling us we did good on that. So just keep in mind, you know, if this is something, you know, of course, if you have not had a chance to practice yet, since we finished chapter 5, then just work a little bit on the different types of examples you had through chapter 5, just to make sure you're comfortable, you know, working with these system of equations. Okay. As you can see, they're asking you to solve this logarithmic equation. This will, of course, be again from chapter 4. So what are we going to do to find our x value here? Very nice, Brandy. Yeah, put this in the exponential form. So what will this look like when we put this in the exponential form? So log of x with base 2 equals 3. When you put that in exponential form, what will you have? Yeah, Brandy, remember your base will always stay the same. So since your log has base 2, your exponential function will also have base 2. Jack, same thing. Since our original base is 2 over here, our exponential function will keep that same base. So it would actually be 2 raised to the 3rd power equals x, and looks like Mikhail, you had that one. And of course, then you're just finding out what 2 to the third power is to get your x value. So remember, the base will always stay the same. So this base a over here is going to be your base a for the exponential function. Your logarithm always equals an exponent. So whatever is your, your log function is set equal to, that's going to be your exponent. So a to the power of y equals x, and that's what you are using, over here to make this conversion. So what do we get for our x value once you simplify that? Two to the third power will give us 8. Very nice. 2 times 2 times 2. Yeah, Maya and Katie, good job. So that comes out to be 8 in this case. And, again, you can do a quick check over here. Okay, this one, I know we had talked about this. It may not have been the same question, but basically, as you can see, they are giving you the equation and they're asking you to determine the foci. They're talking about equation of the asymptotes, sketching the hyperbola. So if you just even look at that question statement over here, you can see they are basically talking about a hyperbola. So there should be no confusion that this is an ellipse. Even if you look at the graphs on the right-hand side, you will of course see those are all hyperbolas. And we know this is a hyperbola because of that minus sign. When it's a plus sign, that's when we know it's an ellipse. So by default, with the minus sign, we know it is going to be a hyperbola, and they're actually even telling you that. When they talk about equations of asymptotes, again, we know they're talking about hyperbolas over here. So let me ask you, is this hyperbola opening left and right, or is it opening up and down? So looking at the equation, what do we know? Okay, and Brandy, what is telling you that it's opening up and down? What was the indication? Or what did you use to indicate that? Okay, that's what I was kind of thinking you were leaning towards. So that only works with ellipses, the larger denominator. Remember, for hyperbolas, you actually have to look at which variable is the first variable. So since the x square is the first variable, we know this guy is opening left and right. Okay, so that means automatically in your graphs, you can eliminate anything that's opening up and down. So you can see graph B is basically gone. But you still have 3 choices to choose for your graphs. So let's talk about finding the foci and equations of the asymptotes, and then we'll come to the graphing section over here. So do you remember how do we find the foci for hyperbolas? Right, we need to find the C value. So for that, we need to know what is the relationship between A, B, and C. So let me see, Brandy, you've got A square. I imagine you meant to say B square equals C square. Very good. With hyperbolas, we use the, the relationship like it is the Pythagorean theorem. So very nice. For the foci, and again, guys, since this is a hyperbola opening left and right, remember for our foci, they would fall on the x-axis then, which means its ordered pairs would be C0 and negative C0. So let's find C value first, and that's going to use A square plus B square equals C square. Remember, in hyperbolas, A square is always the first denominator, b square is always the second denominator. And that will stay the same even if it's opening up and down. So your a square is going to be 4. B square is going to be 16. So let me see, what do you get for your C when you simplify this? And remember, you need to simplify your radicals. Don't leave them as decimals because they want an exact answer. Maya, very nice. Yeah, because 4 plus 16 of course adds up to 20, and then when you end up taking a square root, you basically get C equals square root of 20. 20 can be broken down into 4 times 5. So of course square root of 4 will give us 2, and that 5 will continue to stay inside the radical. Okay, so very good. Your foci are then going to end up being 2 square root of 5, 0. He does not want to work. And negative 2 square root of 5, 0. Now, as far as the asymptotes go, do you remember what is the form of the asymptotes when your hyperbola is opening left and right? It's y equals plus or minus something. What's that fraction for your asymptotes? Is it a over b or is it b over a? Randy, very nice. For hyperbolas opening left and right, it is always going to be b over a. So Maya, Brandy, yeah, very good. So of course, if your b square is 16 and a square is 4, what is this fraction b over a going to look like? Um, 4 over 1. Okay, think about this again. If b square is 16, b is going to be square root of 16, right? So square root of 16 is going to be 4. If a square is 4, then yeah, Hannah, very nice. If a square is 4, then square root of 4 is going to be 2. So your fraction, will come out to be 4 over 2, which again, being a fraction, you can simplify that. So you will actually have y equals positive or negative, 2x. Because Brandy, for it to be 4 over 1, your a square value would also have to be 1, right? Okay, good. Okay, so we've got our foci, we've got our asymptote. So let's put those numbers in. So let's see, this should be 2 square root of 5 and 0. And then our second ordered pair would basically be negative 2 square root of 5 and 0. Our equations, and I think I had made that mistake in your class last time. They are telling you type the equation of the asymptote that has the positive slope in the first box. So we want to put the positive slope in here first. So that's positive 2x over here and negative 2x over here. Now, how do we decide which graph is it going to be? This is graph A. Okay. This is graph C. This is graph D, and of course we already talked about how graph B is opening up and down, so he's not in the running. So now how do you decide which graph is it going to be? So looking at your equation, can you identify what your intercept should be where the graph would be crossing the x-axis? Yeah, remember that's going to be the denominator underneath the x value. So since your denominator underneath x squared is 4, that tells you your x-intercepts, oops, our x-intercepts in this case are going to be a0 and negative a0. So those will end up becoming 2, 0, negative 2, 0. So that should hopefully help us out a little bit. So if you again look at graph A over here, you can see we're going, if you look at those numbers on the x-axis, you're going from positive 6 to negative 6. So that's definitely, you know, breaking each one of these down into 1. So this is going to be, you know, negative 2. And this is going to be positive 2 over here. Now you just have to verify the slope of your asymptote. So, you know, start at the origin and you can see we have a slope of basically 2 over 1. So if I go up 2, I should have just have to go 1 unit to get back on the line. So you will see I am not getting back on the line over here. So, you know, of course, graph A is not going to be our graph. So he's gone. Let's look at graph C over here. So with graph C, we've got, again, this is going from 6 to 6. So this guy is definitely going to be negative 2 over here. This guy over here, of course, would be positive 2. Now you want to verify the slope. So you can again see the y-axis is also broken down into ones. So we should have to go up 2 units and come to the right 1 unit. You should be back on the graph, which we are. Even if you use that slope of 4 over 2, you can see this is also working because if you go up 1, 2, 3, 4 units and then come to the right 2 units, you are obviously falling back on the graph itself. So as you can see, you know, this graph C is definitely working in our favor over here. And just to verify that graph D is not going to work, you can see how your x-intercepts are in the wrong place because your x-intercepts are at positive 4 and negative 4. So, you know, obviously that guy is not going to work. So it's going to be graph C over here. Let me get rid of this stuff. So just, you know, some techniques to help you choose your graphs and, you know, of course, answer the questions that they are asking you to come up with in this case. So let's do a check on this again. You can see they're telling us we did good. And, you know, of course, you would kind of use the same kind of strategies if you were given a ellipse question instead of a hyperbola. Just to remind you with an ellipse question that the relationship between A, B, and C is not going to be the same as hyperbolas, right? So do you remember what's the relationship between A, B, and C for an ellipse? No, Maya, it would not be a minus b. It's similar to, you know, what we had with the hyperbola, where you had a squared plus b squared equals c squared. So in that sense, what's the relationship between a, b, and c for an ellipse? Okay, so you're saying everything should be squared. Yeah, and that can work. So basically, again, you can remember it in the format that Maya is talking about, or basically it's going to be a squared equals b squared plus c squared. So, you know, if you keep the same order like we have for the hyperbola, it's a squared plus b squared equals c squared. You know, like I said, you know, think about the Pythagorean theorem. So what happens with an ellipse is basically, you know, the plus and the equal to sign end up switching places. So you can see with the ellipse, you're just switching the places of the equal to and the plus sign. Or like Maya has in the chat, you can also write this as a squared minus b squared equals c squared. So whatever helps you remember, you know, just find a way that will help you remember these easily. Okay, very nice. Okay, I'm pretty sure we have looked at this example, but again, just very quickly to walk us through, you know, you want to think about if there will be any symmetry, which as you can see, this is x to the third power function, and then you have plus 1. Remember, for the constant terms, we think of them as being an even power. So you've got x to the third, which is an odd exponent. But then when you have the plus 1, we think of that as an even exponent because, you know, technically we think of that as being x to the 0 power. So since this is a combination of odd and even, this will have no symmetry. So then you can talk about the behavior at the x-axis, right? Is it going, excuse me, is it going to cross, or is it going to, you know, touch, which in this case, you can obviously see from all the options that are given to you in your graph, it's definitely crossing at the x-axis. So I would say figure out where the x-axis is going to be. So that way, again, you know, are you going to be on the positive side of the x-axis or the negative side? And then use your leading coefficient test. That's the best thing you can do. So in this example, we have no symmetry to work with. So look at the behavior of your x-intercepts and look at what the arms of your graph are going to be doing. So figure out where that x-intercept is and then use your leading coefficient test. And remember, this is where we talk about if you have an odd or even exponent, and then you have a positive or a negative leading coefficient. So in this case, you know, of course, we are looking at odd and positive. So odd and positive. And again, I remember mentioning to you guys, you know, think about something like y equals x, which is a straight line with a positive slope. So we know as x goes to infinity, so as x goes to positive infinity, y would also go to positive infinity because that's this arm of our graph going up. And then as x goes to negative infinity, which would be this arm of your graph, going down, you can see your y is also headed to negative infinity. So you should have this general shape of your graph, going up. So that means you are looking at graph D and graph A, because you can see in graphs B and C, as x goes to positive infinity, your y values are headed to negative infinity. And so, obviously it's not going to be these two graphs over here. So now how do you decide, is it graph A or graph D? What are you going to do? Because we know the general shape of our graph, but is it going to be A or D? So where do you think the x-intercept for this function is going to be at? Excuse me. Okay, Maya, you're saying your x-intercept is at 1. Remember, for the x-intercept, you just take your function and set it equal to 0. Basically, you're making your y value 0 to find your x-intercept. And then solve for x. So we would, subtract the 1. Then we would divide by 3. And you would end up getting x cubed equals negative 1/3. So your x would basically come out to be cube root of negative 1/3, which would be, negative something. So Maya, it's not going to be exactly at negative 1, is it? But you don't need to know the exact number. We know it's going to be a negative number, because when you take a cube root on a negative number, you always end up getting a negative answer. Actually, that should be. So you can technically just think about bringing that negative sign outside, and you can have negative cube root of 1/3. So we know our x-intercept has to be on the negative side, which is what you have here in graph D. So let me make this guy bigger. This is our graph D, and you can see your x-intercept is on the negative side over here, whereas with graph A, you can see it's crossing our x-axis on the positive side. So that automatically tells us you are looking at graph D for your graph, because that's where your x-intercept is on the negative side. So you don't have to have the exact answers, because they're not asking you to type in where the x-intercept is at. They just want you to be able to choose your graph. So just use these techniques to help you out, so that you get a good idea of what you're doing. Techniques, keep it simple, don't make it too complicated if they're not asking you. This guy here is coming from chapter 1, and I do remember working on this. So remember, this is where you find your least common denominator, and my that make denominator 0, which is that you can definitely leave out. Katie, the screen got blurry again. Yeah, and I had a feeling it would do that over time. It's been cooperating with us for now, so it had to act funny eventually. Okay, so I've shared it again. I don't know if that made it better. A little bit better, okay. So again, remember, identity, all real numbers except those numbers that make your denominator 0. If it's conditional, then remember, you only get 1 or 2 answers, which in this case I would imagine just a single answer, and then it got better and it's gone bad again. And then when it's an inconsistent equation, remember that means your equation has no solution at all. You basically don't come up with an answer. So again, this is from chapter 1. And since we had looked at this last time, I did not want to spend too much time talking about it. Graphing with your logarithms, let me ask you, how would you go about doing that? And did the screen get any better, or is it still blurry? It got better. Okay, that's good to know. So can you tell me what would you do to find these ordered pairs and then to graph your function here? So when you've got, log of x with base 2, and they're asking you to find, these ordered pairs where your x values are 1/2, +1, and +2, what do you get? And how do you solve that? What would you guys do here? So would you convert these into exponential notation? Would you, technically, you could do so many different things. You could do a base change formula. You can, just kind of look at this and see what you have. Converting it to exponential notation is, of course, the most common thing that we normally do in these situations. So basically what they're asking you to do is find log of 1/2 with base 2. They're asking you to find log of 1 with base 2 and log of 2 with base 2. So if you convert this to exponential notation, these would be all our unknown values, because, we're finding the y values here. So these would be unknowns. So if you're converting these into exponential notation, you would have 2 to the power of y equals 1/2. But remember, you can write 1/2 as 2 to the power of -1. So in this case, you would end up getting y equals -1. So this guy here would be -1. Remember, logarithm, log of 1 comes from the 0 exponent rule. So in this case, what would happen over here is if you try to convert this into exponential notation, you would have 2 to the power of y equals 1. And the only time you get the answer 1 is when you would have 2 to the power of 0, which means your y value would have to be 0. Or honestly, just plug in log of 1 in your calculator and you will see you end up getting 0 as your answer. So log of 1 is always going to give you 0 no matter what the base is. And then for the last one over here where they have log of 2 with base 2, of course, since your bases are the same, you've got 2 to the power of y equals 2. And by default, we know if there's no exponent, it's understood to be exponent 1. So you would have y equals 1 over here. So this is one option, or like I said, you can always do the base change formula. And if you use the base change formula, then you would rewrite this guy as, log of 1/2 divided by log of 2. For the second one, you would write it as log of 1 divided by log of 2. And, of course, for the last one, you would have log of 2 divided by log of 2. So, of course, you're dividing the same logarithm. You would, sorry, this should be 1. This guy over here, the numerator for log of 1 is going to be 0. Like I said, logarithm of the number 1 is always 0. So it would be 0, over some number. So 0 divided by a number is always going to be 0. And once you simplify log of 1/2 divided by log of 2, you would basically end up getting -1 as your answer over here. So you can use base change formula, exponential notation, whatever helps you out. Now, as far as the graphing for these goes, I believe, if I remember correctly, this is where that little box will pop up. So make sure you are selecting the logarithmic tool, which is going to be this one over here. Click on the graph, and you will see this little window pops up. All you have to do here, because this is a simple logarithmic function, you have log of x with base 2. There is no shifting or stretching or any of that happening. Just go down where it says base e and take that e, remove it, and change it with base 2, because your logarithm has a base 2. That's all you have to do, is change that base and save your graph, and you are good to go. Okay, so we've done the log, ordered pairs, we've got the graph. Now, can you tell me what the domain and range for this function is going to be? Looking at your graph, what is going to be the domain and range for this logarithmic function? Nobody?
Sorry, what was the question again?
The last two on your screen, what's the domain and range for this function that we have up here? And Brandy, is that for the domain? Okay, so you're saying 0 to infinity. Very nice, yeah, because as you can see from our graph over here, remember you have vertical asymptote right over here at the y-axis. So this arm of our graph is getting closer to that y-axis, but it won't touch. So that means you are starting at 0, not including 0 at the domain. And then, of course, this arm of our graph is headed towards infinity. So we know you are headed to positive infinity on the domain. Okay, very nice. What can you tell me about the range for this function? Okay, let's see. Brandy, you are saying negative infinity to positive infinity, and Braden looks like you have the same thing. Okay, so let's take a look at that. So yeah, very nice. As this arm of your graph is headed downwards, of course, like you said, on the y-axis, that means you are headed to negative infinity, but this arm as it goes right is also headed up. So he's going towards positive infinity. So very nice. As far as the range goes, it's all real numbers. You're going from negative infinity to positive infinity. And another thing to remember is, remember how your domain and range switch places from exponential functions to logarithmic functions. So that's another thing to keep in mind. Alrighty, very nice. So looks like those were the questions we had over here. So let's do a check on this guy. Looks good. And of course, that is again from chapter 4. We had looked at a similar question like this last time. So this is again coming from that leading coefficient test in chapter 3. So just looking at the leading coefficient and the leading term, which would be 5x to the 7th, you need to decide, would you be headed towards positive infinity, negative infinity, that kind of thing. So you can see the degree of our polynomial is x to the 7th, which means that 7 is an odd number. You can, of course, see our leading coefficient is positive 5. So that's going to be a positive leading coefficient. So when you have odd and positive, is your graph headed to positive infinity or negative infinity when x goes to negative infinity? So what would we choose here, positive or negative infinity when it's an odd degree with a positive leading coefficient? Negative infinity, very nice. Remember, for odd and positive, you can just think of the graph, and we had actually just looked at this before. You can think of the function y equals x, which is a line going up. So as x is headed to negative infinity, you can see your y is also headed downwards to negative infinity. So very nice. This guy would equal negative infinity. Alrighty, very nice. Okay, quadratic function. They're asking you to rewrite this in the standard form, and honestly, I have a feeling we had done this question also last time. So this is actually an easier form of your equation, and mainly because you will see you don't have that constant term of any number being added or subtracted. So since it's only x squared plus 2x, just use your completing the square on this. So you've got x squared plus 2x, and you are just trying to find what that missing term is. And once you find it, remember you can factor it out into a square factor. So when you complete the square, what number would you add at the end over here? Randy, alrighty. So remember, with completing the square, Katie, all right, very nice. With completing the square, you take the coefficient of your middle term, you divide it by 2, and then square the entire thing. So very nice, ladies. 2 divided by 2 gives you 1. 1 squared is 1. So you're actually adding 1 to make this into a perfect square trinomial. Now remember, since you are adding 1, you would also need to subtract 1 from your equation on the same side. So you would be adding that 1 and at the same time subtracting 1. So technically, this would be our trinomial over here, and then you would have the negative 1 on the outside. So we would need to keep that negative 1 on the outside over here. Now, what will your x squared plus 2x plus 1 factor into. Two numbers that multiply to give you 1 but add up to give you 2. So what will this guy factor into? Yeah, very nice, because those two numbers would be 1 times 1. And you know, of course, 1 plus 1 will give you 2. So this guy actually factors into x plus 1. So you would have this as your new function. So you can rewrite this guy as x plus 1 squared. And then, you know, of course, that minus 1 to keep the balance of our equation. So looks like that's what they want us to put in here, is what is the new form of our equation. So that would be x plus 1 quantity squared, and then the minus 1 at the end. For the graph of this, let's see if I can move this a little bit to the right. You know, of course, again, you are selecting the parabola tool, and this one also you will see is actually popping up with this little box. So what information do we need to put in here in this box over here? You've got stretching and shrinking. You've got vertical translation, horizontal translation, and the reflections. So do we need to put anything in the stretching shrinking box? No, because remember that comes from the A value, and we don't have an A value over here because that would be in front of the parentheses and you don't have anything. So we don't need to do anything to the stretching and shrinking. What about vertical translation? What would we do? Would we put anything in the vertical translation box? Yeah, what would you put in there? Yeah, very nice. That's your K value, right? So that's going to be that minus 1 that we have over here. So vertical translation, we would change that to -1. What about horizontal translation? Do we need to put anything in there? Okay, what do we put? Braden, would it be +1 or -1? Because you go with the opposite sign. Remember, for that H value, the horizontal translation, so be careful because those signs will definitely throw you guys off. -1. And then again, remember, the only time you have a reflection is if that A value would have been negative, but you know, of course, we don't have an A value over here, so we don't have to worry about reflections either. So put those values in, you know, save your graph, and you would be good to go. So let's see. All right, this guy also looks good. Let's clear that out. Okay. So, you know, of course, you can see if we're going to do this question by question, that will take us a really long time. So what I would like to do is actually just kind of talk about strategies instead of trying to solve each single question, because that will definitely take a long time. So what I would suggest is I actually need to take a break over here. I am supposed to call my mom's doctor and just verify some things with her. I told her I'd call her at 10:40 because that's when she wanted me to call her. So I'm actually going to take a 10-minute break over here, guys. Just go talk to her, see what she wants to talk to us about. And how about we meet at 10:50? And Hannah, if you have something else you need to do after this, you're welcome to not come back. But if you want to come back and just follow along with the other questions, then you're welcome to come back, okay? Alrighty, so let's take a break here, guys, and then I'll be back at 10:50, okay? All right, everybody, thank you so much.